Good morning, good afternoon, good evening, hello. Welcome to the interwebs where you're watching this video. If you're watching this video on the interwebs, welcome, hello. It is November 23rd, 2021, our last day before break. It is a Tuesday here in beautiful Southern Ohio. Welcome. Let's get started. Today's review slide is the same as yesterday. I still am asking you to find 3 different ways to use sixes to make a sum of 8 6. So 8 6. 8 6 is our value. Okay? That is the value that I'm wanting you to look for. We had the same issue yesterday, and we had much less of this issue today. Much less of an issue today. But I'm asking for the sum. The word sum is code for the answer to an addition problem. Very good. Cameron, what do you want for our first equation here? Give me an easy one.
Okay, I put 2 6 and 6 6.
Why did you choose those 2 fractions, Cameron? Tell me all the thought process that went into you choosing those 2 fractions, please.
Okay, so I was thinking of different fractions, and I went to
Did anyone else have 2 6 and 6 6?
Yeah.
Why did you choose 2 6 and 6 6, David?
Because 6 plus 2 is 8. It just move the denominators along because they're the same.
6 plus 2 is 8, and these denominators have to stay the same. Why is that? Why do the denominators have to stay the same, David?
Because if you change the denominators, you're going to change the size of these.
That's right. So the temptation is going to be to want to do something like this. Whoops. This is going to be the temptation because you're going to want to add these 2 things, which is what you're supposed to do. But then your brain is going to want to add these 2 things. But that's when you have to stop and think to yourself, no. The 6 doesn't change because that is the amount of equal parts that our whole is cut into since we're working with fractions. And so you have to remember that when we're working with fractions here. Okay? Who else has an equation for me? Kelsey.
I put 4, 6, 4, 6.
Does anyone else have 4 6 plus 4 6? Good. Denominator stays the same. 4 plus 4 is 8. Very good. And finally, Sophia, half birthday girl.
I put 2 6 plus 2 6 plus 2 6 plus 2 6. That's good.
2 6 plus 2 6 plus 2 6. 2 4 6 8. Who do we appreciate? Miss McGinnis. Yeah. Miss McGinnis. Yeah. Because we love math. Yeah. We love. No.
Yeah.
No.
Yeah.
Yay.
All right. Who else? Let's see. Could we do 1 6 plus 1 6 plus 6 6?
Yeah.
That's 8.
You can do 7 6 plus 1 6.
We could do 7 6 plus 1 6.
We can do 1 6 1 6 1 6 1 6 1 6 1 6 1 6 1 6 1 6 and 1 6.
8 6s, right? Could we do 3 6 plus 4 6 plus 1 6?
3 6 plus 3 6.
We can
3
do
6 plus 4 6 plus 1 6.
5 6
5 6 plus 3 6.
4 6 plus 2 6 plus 2 6.
4 6 plus 2 plus 2 6.
You could do what I was gonna say.
What you got, Vlad? It's okay.
You could do 3 6 plus 1 6 plus 6 plus 1 6.
3 6 plus 1 6 plus 3 6 plus 1. Very good. We could do a great many combination of fractions to get to 8 6. Today, we are going to continue the conversation we started yesterday about addition of fractions. So let's continue to explore sums of fractions on a number line, shall we?
Yes, we shall.
We did this yesterday, so we'll skip over that. Let's practice this gear shift again. This number line has whole numbers in it. 0, 5, and 10. What is the number? What number does the point describe? What do you think the jumps represent? And what equations can we write to represent the combination of jumps? Sophia, start us off. The first one?
The point represents 8.
8. The whole number 8. What do you think the jumps represent, Riley?
I think 6 and 2.
6 and 2. Riley Kidd, what equations can we write to represent the combination of jumps?
You do 6 plus 2 and 2 plus 6.
Let's finish them off here. What do you want me to write right here? 8, yeah. Very good. So, what I want you to notice here is that this number line is showing you how these jumps translate into an equation. So we're going 6 to 2. We have a plus sign right here. 6 plus 2, and you land on the 8. That is how this number line works, okay? Does everybody see how that works?
Yeah.
Now we're going to switch gears back to our fractions. Now I want you to study these number lines. It says on each number line, draw 2 jumps to show how to use sixes to make a sum of 8 6. Now, handy dandy, isn't it, that the daily review slide had the fraction 8 6 on it? Wouldn't you say? Handy dandy. So, you can use the answer from your review slide to do these, to draw this on this number line. I want your shoulder partner to do one, and then I want you to do one. So you're going to draw on your paper. You got about 2 minutes. Go.
We're going to draw the dice. We're going to go 0 to 1 and 1.
So I think we should do 4 6. Let's see.
Oh no. We're too far. I couldn't see.
Yes, draw on that paper that I gave you.
So what would that be altogether?
You didn't have to explain none of these to me, but I do.
1, 2, 3, 4, 5,
6. That would be
5. No, we're not. So look, here, what is this? 1, 2, 3, 4, 5. No, we're gonna see what the dot is. What's the dot? 1, 2, 3, 4, 5, 6, 7, 8.
2 jumps.
It's a dog.
Okay, so I'm just gonna say that's for whole numbers. We are. Okay, so what are we doing?
Because you don't count on
Zero.
Which grade?
No, dude, this thing's supposed to go to the line.
Because, yeah. I said
How many jumps did it ask for?
2.
2. So I saw some people out there that had 3 or 4 jumps. But here we have one. What do you got, Logan? What were your jumps that you chose? Now, is it the whole number 4? What is it? What's my equation going to be? Because now we need to also write an equation. So what's my equation going to be here?
4, 6 plus 4, 6 equals 8, 6.
Excellent. Everybody give Logan 2 big claps. Good job. Who's got the next one? Vlad.
I did 5 and 5 and 3.
And so what's my equation going to be?
5 plus 3 equals 8, 6.
Got 5 holes.
I mean 5, 6
Yep.
plus 3, 6.
Good job. Very good.
Good job.
And there's another one that we could have done. There's only one more we could have done if we were only going to do 2 jumps. What is it, Allie and James? I don't know. You had your hand up. No. Oh, yeah. No, that's it. Yeah, that's it.
We could do a jump of 6.
6, 6, and
2, 6.
2, 6. 6, 6 plus 2, 6 equals 8, 6.
You can also do 7.
Go ahead. Go, Jake. You're right. I'm wrong.
You can also do 7, 6.
We could have also done 7, 6 plus 1, 6. Very good. I was wrong. You're right. Good work. Very good job. Now, we also could switch any of these. We could do 6, 6 plus 2, 6 or 2, 6 plus 6, 6. We could flip any of these except the 4s. Obviously, that would stay the same. We're allowed to flip those add-ins, right? So, yeah. All right. Let's look at letter B. And you have your paper there with your partner. Let's look at letter B. Noah draws the following diagram. So here is Noah's diagram. He writes 2 different equations. He writes 8, 6 equals 6, 6 plus 2, 6. And he writes 8, 6 equals 1 plus 2, 6. Which equation is correct? Take 30 seconds to think on your own about which one of these equations is correct. Shh. You're thinking on your own right now. You can use your screen. You don't have to use the paper. I'm asking you which one is correct.
I know. Because 6 plus 2 is 8 and then 6 6. But 8, 6 is 1 plus 2, 6.
Talk to your shoulder partner about what you think.
Somebody
Because 6, 6 equals 1.
I think it's yeah, 6. It's a whole. So we raise our hand. 6 is a whole. We should raise our hand. So I'd say
So you read it.
this is easy.
Yeah, you're supposed to be talking to your shoulder partner.
It's both. Yeah, it's both, but
What do you think?
it's both.
It's both. What do you girls think? Why do you think it's both, Cameron?
Because
I think I'd be like 6.
I can look at
What do you think about David?
And my mom doesn't have enough money to get bagel bites.
What'd you think, Allie?
So I think they are both correct because they're actually both like the same because 6 plus 6 is a whole and there's a 4 over there. And okay, so there's 6 plus 2 6, so 6, 7, 8, and you do not change the denominator. So then that's equals 8 6, and then the other one is a whole plus 2 6 because the whole is 6 6 plus the 2 6. So they're basically the same thing. You're just putting it as a whole.
They're basically the same thing. One says 6 6. This equation here says 6 6. Yes? And this equation here says 1 whole, correct?
Yes.
They mean the same exact thing, though. Very good. Okay. Very good. On your paper, it says, again, on each number line, draw jumps to show how to use thirds to make a sum of 7 thirds. Then write an equation to represent each combination of jumps. Now, this time, you are not being required to only do 2 jumps. It just says a combination of jumps. So, you and your partner, you have like less than 1 minute. You do one and then let your partner do one.
So,
Listen to her.
I'll do the first one, then I'll go to here. Same as that. 3 and 4. Now you can do that 1 third, and then you do whatever. 4 more. Which would equal 4. You go 4 more. Did you know you can go past 7? Nope. I knew. Yeah, because that's what you know.
I mean myself right then.
Specific. Really?
Hey Cameron, you ever just accidentally push back on us?
Don't.
I use an accident.
Because it's in the middle.
It was an
It's
accident.
in the middle.
Is there another way?
So,
Make sure you have your equation too.
shoot.
Oh wait, we don't.
There you go. So what's your equation going to be?
We have to do it different.
2 different ones, not the same. Did you do the same thing
How do you do yours?
as David?
I wrote mine down 11 times.
Well, because I didn't know.
Well, Hassib, why would you want to write the same thing, silly?
I didn't know.
Yeah, I didn't know, man. I didn't know.
Okay, so what am I going to do? I don't know.
Why don't you just put Rocky Spence on my skull?
So why did I don't know what to do.
No, wait for B. Do not do B. We'll talk about B together.
I don't think so.
Is that a 2? What's 4 plus 2? No, 5 plus 2. That. You ever snap a pencil on a you gotta read it. At least we know the answer.
This is 3. This is 3.
My it's easy to break pencils on my head.
All the way to the 2 and then
Wait, where do I practice here?
Class?
Yes.
All right. What do we got? Kelsey. Anybody else have 4 thirds plus 3 thirds equals 7 thirds? Good.
Wait, is that? Not.
Because this is 1, 2, 3, 4 thirds. And this is 1, 2, 3 thirds. 7 thirds. 4 thirds plus 3 thirds equals our dot here is 7 thirds. What do we got for the next one? Jake?
Next one we have
2.
1 plus 1 plus 1 plus 1 plus 1 plus 2.
1 plus 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 2?
Yeah.
Okay.
That's a big one.
1 third.
I just
1 third.
Legit.
2 third. He's making me work, ain't he?
Yeah, I did that.
7 third.
Jake, you think the biggest one ever?
1 third. Plus 1 third.
It's the longest one, not the biggest.
Plus 1 third. Plus 2
Yeah,
third.
that's the admin.
Equals 7 thirds. Okay, is he right?
Yeah.
Sure. Raise your hand if you had something different. I think I should see probably every single hand in this room. Because I saw 5 thirds plus 2 thirds, 6 thirds plus 1 third. 1 third plus 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 1 third. Right? All kinds. There's all kinds. Now, let's write 7 thirds as a sum of a whole number and a fraction. Did anybody do that? Kyrie?
I actually did that for my answer on the question before it, so I already know the answer.
So what is it?
2 1/3.
I want it as a sum of a whole number. That's not as a sum. We're struggling with this word sum. We're either forgetting what it means or ignoring it entirely.
Oh, right. 2 plus 1/3.
Atta girl. Thank you. 2 plus 1 third equals 7 thirds. Now, you may look at that and think that that looks very strange. Here's what you have to remember. We have these thirds right here. That denominator tells us the size of the pieces. Okay? And so when we have 2 wholes, we know we've got 2 wholes. And they have to be in thirds. So in order for me to have something that's all that one whole thing cut into thirds, how many pieces am I going to have? 3. But here I have 2. So it's 3 thirds. When you see this, when you see 2 plus 1 third equals 7 thirds, what you actually see is 3 thirds plus 3 thirds plus 1 third. Does that make sense?
Yeah.
Because you've got 2 holes right here. We call 2 1/3 a mixed number. Why might it be called a mixed number? Put your hands down. Who has already seen a mixed number somewhere before in this room? All people, I think. We've talked about them before. But why might it be called a mixed number? Kyrie, why is it called a mixed number?
Because it's a whole number and a fraction.
It's a whole number and a fraction kind of smushed together to make one whole number. This is 2 1/3. When I have one thing, 2 things, and 1/3 of a thing, that is my number, 2 1/3. That's my answer. That's my number. That's a full number, 2 1/3. It's called a mixed number. Okay? All right, turn your paper over. Excuse me. This is where you really need to use your Chromebook and put the slide deck in present mode so that you can see those teeny tiny itty bitty tick marks. And if you are online with us, we'll get through this together. All right? What do you notice about the numbers? So here are our numbers. What do you notice about the numbers? What do you notice about the number lines? What do you notice about the numbers? Let's think for 30 seconds on our own before we start sharing out. Let's think for 30 seconds on our own before we start sharing out. What do you notice about the number? What do you notice about the number lines? Riley, what do you notice about the numbers?
There's only one whole, but it looks like there should be more.
Ooh, because what do you know about this number here?
It's 11/8.
Which means it's greater than
Uh-huh.
one whole thing, right? He says that there's only one whole number here, but it should be more than that because I know this one's greater than a whole. This one's greater than a whole. This is greater, right? He's noticing all these different holes here. That's great. Kelsey? All of the denominators are all 8s. So what does that mean about our number lines? Our number lines are all going to be the same. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Here is our one holes in the same spot. So do we have our matching number lines? Who noticed that they had the number lines were all matching? Very good. Okay. So here's the same number line again. Use a number line to represent each addition expression and to find its value. So now what we're doing is taking these fractions and plotting them on this number line. Before, what they did was they gave us the dot and told us what the dot was and let us make the jumps. Now they're giving us the jumps to make and wanting us to tell them what the dots are. So look at that first one. You're probably going to have to use your paper or your screen because you're not going to be able to see it up there on the big screen. Talk to your partner about what you think.
Where will the dot be? In your own this right here.
Don't move on. Just do the first one.
What do you think? What do you think A is equal to? Where do you think it's not?
She hasn't even loaded yet.
Still. All right. So my first number in my expression is 5/8. And I know that my one whole is that this one section here is divided into 8 parts. We talked about that already, correct? So, we have 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5. Yep. 6, 7. So I did 5 jumps and 2 jumps. Is that what you did?
Uh-huh.
Is that what you did on your paper? Good. And that landed me where? 7/8. When I use a number line to represent fractions, the total amount of sections between the 0 and the 1, that's my denominator. Then whatever my hops are, however many hops I have, that's my numerator. Yes. It's okay. No, it's not a big deal. 1/8 plus 9/8. What do you notice is probably going to happen with this answer? Over what? It's going to go beyond the 1, right?
Uh-huh.
So my first jump is going to be how many tick marks? 1. And my second jump is going to be how many tick marks? 9. And that's going to put me at what? 10/8. 3. 1, 2, 3, 4, 5, 6, 7, 8. There should be one more. That's right. There it is. 10/8. 1/8 and 9/8. So on B, our second jump went beyond the 1 with our second jump. What do you notice about C? It's okay. You don't have to write it down. Don't worry about it. What do you notice about C? What's going to happen, Vlad?
It's gonna be above one hole.
When? On the first jump or the second jump?
The first jump.
That's right. So my first jump is going all the way to here. And then how many more do I need for my second jump, Nehemiah? I need 9 for my second jump. Nine. So what would my answer be, Kelsey? 28. Very good. A lot of 8s. Now, what is going to be my best course of action to help me draw an accurate number line for D? I have 1 hole here. Would it be helpful to label something else on my number line before I get started with my jumps? Riley?
See, the 1 hole is at 8/8, right?
Uh-huh.
So 2 holes would be 16/8.
So should I just go ahead and mark the 2?
Yeah. Go
8,
ahead and mark
9, 10, 11, 12, 13, 14, 15, 16. So here my 2 would be.
So then there would
I'm
be.
just going to go ahead and mark the hole for 3 too.
So you would. So for your jumps, you would do. So you would do 1. So you would go to the. So sorry to explain. You would go 1.
You want me to stop here?
Yeah.
I don't want to stop there because, like I said, this is 1 number.
Wait. So then you go past. Once you go past 1, you go 1 past 2. Do you go only? No. You go 1 more. Because it has 1/8. So
Yep.
it would go past the 1 by 1. Go past the 2 by 1.
Right there.
Yep.
My brain.
And then you'll do 4 more.
4 more.
Yep.
I forgot that existed.
And then what's my answer going to be?
Your answer is going to be.
You can write it as a mixed number or as a.
Let's see. 2 times 8 equals 16.
Hold on. Why are you timesing? We're talking about sums, addition, expression.
My brain's going on.
Look at your number line. What do you have?
17.
17.
17 plus 4, so 20? No. Yeah.
and 1/8. What if I wanted to write that as a mixed number? If it's just sitting still, we don't have a need for pencil right now. So if it's just sitting still, we don't have that problem. You can also write this as a mixed number. What would our mixed number be? If I have 2 and 1/8 here and I add 4/8 to it, what would my mixed number be?
It would be 2 and 5.
2 and 5.
2 and 5/8.
That's right. 2 and 5/8. Very good. All right. Let's keep stretching those fractional number line muscles. Priya says the sum of 1 and 2/5 and 4/5 is 1 and 6/5. Is she right?
What? Hold on.
She says the sum of 1 and 2/5 and 4/5 is 1 and 6/5. Is that true?
Yeah. Yes.
No.
Talk to your shoulder partner. What do you think? Yes or no?
Yeah.
Yeah.
Yeah, because 4, 5 is the same. 4 for 6.
Okay, so that one.
So look, you got okay, so 4 and 2, 4, 5, 6, and then keep the 5 the same. So it's true. It's right.
Yeah.
Thumbs up. It's awesome.
What do you think? Thumbs up for true, thumbs down for false. So I have a lot of thumbs up and a couple thumbs down. Let's look at this. Let's look at this. If we put these two together, how much is that? 6/5. And if we keep this whole, it's going to be 1 6/5. Now, are there other ways we can say this?
Yeah.
What's one other way we can say it, Vlad?
2.
And
2.
Huh?
I said 2 1/5.
2 1/5.
It's going over.
Because see your extra one right here? So you would put those in with 2 1/5. Good. Chiron says the sum is 11/5. Oh, use one or more number lines if you find them helpful. So look, we can do this way. So we can do Priya here, Chiron here, and Tyler here. So Priya says 1 2/5. So we have fifths here. Look up here. 1, 2, 3, 4, 5 is our one whole cut into 5 pieces.
Yes.
1, 2, 3, 4, 5. Yes. So there's one whole and 2/5. And then 4/5 lands us right here. Chiron says the sum is 11/5. So 5, 6, 7, 8, 9, 10, 11. Is that right?
Yeah.
They're both right.
What about Tyler?
Yeah. Right too. Vlad said it's equals 2 1/5.
Riley says Tyler's right too because Vlad says it equals 2 1/5. Was Vlad right? Does it equal 2 1/5?
Yes.
He was right. It does equal 2 1/5. Whoopsie. Too far. 2 1/5 here. So, what does this mean? Priya is 1 6/5. Chiron is 11/5. And Tyler is 2 1/5. What do these number lines show about these three numbers here? David? That they are all equivalent. Very good. I want to get right here. Today we use number lines to decompose fractions into sums of smaller fractions or sums of a whole number and a fraction. We also learned that a fraction greater than 1 can be written as a mixed number. We already knew that, right?
Yeah.
In your cactus notebook, talk to your shoulder partner for a minute. I want you to say, how would you explain to a classmate who is absent today what a mixed number is?
We done it yesterday.
Go ahead, do it right now. All right, this concludes our math recording. Happy Thanksgiving, everyone. We'll see you next time.
Fraction.